All right, welcome to today's presentation, tips and tricks. I will mute everyone to avoid any noise, background noise. All right, so this is the 9th edition of the tips and tricks, research tips and tricks. And we will be looking at the issue of the p-value. The issue of the p-value. And I think we all use this in our different areas of work. Sorry if I stop sharing this. We use it, so we will see what are the implications we have when we use the p-value. In recent times, there has been some issues in the way the p-value is being misused. All right, so I will, as usual, divide you into 3 groups and send you quickly to breakout sessions. What I would like you to do there in the breakout sessions, I will put it on the chat box. There will be 3 groups. There will be 3 groups. So from the file that will come to the chat box, you will recognize which group it will be. And so you can pick the file that comes. Do you hear me clearly? Do you hear me clearly? You can give a thumbs up, because some are complaining they can't hear me clearly. If you hear me clearly, let me see. All right, great. So, all right, Tahirid, then you have to check your site, what's happening. So I've put 3 papers on the chat box. You can see group 1, group 2, group 3. They are abstract of scientific publications. So depending on the group you fall into, when I assign you now, look at that abstract. You can discuss about it in relation to the issue of p-value. Do you see p-value there? How was it used? Is it used appropriately? When you come back, we will continue on that. I'm not going to allow you to present your thought when you come back. We'll get into the presentation and I will come back to what you have discussed in your group. So please take note of that, and I will send you to the breakout sessions automatically now. All right, so please join your room. Join the room you find yourself in. So in 10 minutes time, I will bring you back. Read the abstract, discuss it, and let's see what thoughts you get from there. All right, I see that most people are back, if not everyone. And I hope you got some insight into the small text you have. It's not the extended text, but for those who have attended the SFI course on the art of scientific writing, which we have sent out the advert and will be running in December, one thing that comes to mind is when you write your abstract as a as a scientist in a scientific paper, the abstract is the first thing that readers see. Is the first thing that readers see, and then it is also what the when you send it to the journal, what the editors will read first after your cover letter, and that will give them an opinion what to do with your paper. So the abstract is very important, and that is why I gave you the abstract. And then because we do not have time for you to read everything that is there, so the abstract gives an enormous amount of impression of what you have done in your paper. So I hope that what you have done, what you have read, you are able to tell somebody, well, this paper is about this, is about that, to some extent. And if you are not able to do that in the paper you have looked at, it means there is a problem with that paper. All right, so that we just came back from that. What is the p-value? What is a p-value? You see, the p-value is one of the most misunderstood, misused, misconstrued, and several misses there you have in the scientific literature. Majority of people who use the p-value don't understand what it is. All right, to the extent that many of us have taken it as a validation of what we have done in our study, a validation of our results, a validation of our research process. But that is not what the p-value is about. All right, so I want to briefly, in these tips and tricks, it's not exhaustive, to appetize you so that you can go and look at it more carefully. All right, so in the context of statistics, we have what is called hypothesis. All right, you start a study, and then you look at what you're going to study, and then you make a proposal. No, the hypothesis is like a proposal. You make a proposal that what I'm going to study. Let's say, for instance, that COVID-19 affected people's mental health due to the lockdown. All right, that is your proposal, and then you want to study that. When in the context of hypothesis, you would like to state what we call the null hypothesis, and that null hypothesis is that the COVID-19 had no influence on people's mental health regardless of the lockdown. That is null hypothesis. All right. And now, when you go out and collect your data, remember that not the hypothesis stated before you even make attempt with collecting your data. You go out, you design your study, you collect your data, you come, you analyze it, you do everything. When you are making your statistics, you want to disprove or reject that null hypothesis to actually indicate or show that COVID-19 had influence on people's mental health due to the lockdown. And so to be able to reject that hypothesis or disprove it, statisticians generated a number that will give you an indication whether the null hypothesis is true or it should be rejected. All right. And that number that will give you an indication of whether the null hypothesis is true or should be rejected is called the p-value. So is that number that is calculated from a statistical test that describes how likely you are to have found a particular set of observations in the null hypothesis, if the null hypothesis were true. If the null hypothesis were true. All right. It is the number that you calculate from your statistics that describes how likely you are to have found a particular set of observations if the null hypothesis were true. And this number lies between 0 and 1. All right. The smaller that number, the more likely that the null hypothesis should be rejected. The bigger the number, the more likely that the null hypothesis is true. All right. So it lies between 0 and 1. And this tells the researchers the probability of observing a certain value, given that the null hypothesis is true. And the p-value is used in hypothesis testing to help decide whether to reject, as I said, the null hypothesis or not. All right. So that is what the p-value is. It is that number you calculate. Now, from what I have explained to you, perhaps something is coming to your mind. What is it that will indicate to you? What is it that will indicate to you that COVID-19 had impact on mental health? What is it that will indicate to you that COVID-19 had impact on mental health? The p-value does not give you that information. The p-value is only telling you, when you state your null hypothesis, that there was no effect, there was no impact of the COVID-19. The p-value is telling you that, yes, what you have calculated shows that there was no impact, or what you have calculated shows that there was an impact. That's what the p-value is telling you. But the p-value does not give you information on what you have actually calculated, what the impact is. For instance, if we had lockdown, how many people in the population, or what proportion of the people in the population would have mental health? The p-value does not give us that information. All right. So I want you to get that point, that beyond the p-value, there is actually something we set out to do to see whether the COVID-19 had impact on mental health. And that is the core issue we're trying to address here. But the p-value, because we have stated a null hypothesis, the p-value is there then to help us to know whether the null hypothesis is true, that there was no effect, or the null hypothesis should be rejected. Now, when you talk about null hypothesis, we also have what is called the alternative. Alternative hypothesis is the opposite of the null. So if the null is there is no impact of COVID-19, the alternative would be there was an impact of COVID-19 on mental health. All right. So sometimes it may not be an alternative hypothesis. It may actually be that you are stating clearly that the impact of COVID-19 on mental health is of this value. All right. In the context of statistics, I wouldn't go deep into that, but we'll have what is called two-tailed test and one-tailed test. When you are setting, you give a particular value, then you are approaching the one-tailed test. All right. When you are not setting, then you have two-tailed test. It could be either side. All right. Quickly to say that I have defined the p-value, and I think you may be happy with what I've said, unless you disagree. Anyway, we actually, when we do our research, this is what we do. We formulate our questions. All right. We formulate, we generate hypotheses. We go and collect data, make experiment, as the case may be, depending on the context we find ourselves. We bring the data, we analyze the data. As you can see, when we analyze, then we interpret, report, and publish. All right. You see, there is a web of activities that we do, from making our questions, collecting the data, analyze web of activities. All right. And in this web of activities, if you're dealing with human beings, naturally, the first thing people would do is to randomly select participants from a population. And then you collect data from them. All right. After collecting the data from them, you analyze the data, then you interpret the data. You see, what I've explained now, it looks and sounds simplistic, but it is quite a challenging process. We are not sure that the random sampling you have done is actually random. Well, you may implement the random sampling, but what happens is that when you have randomly assigned the people, of those you have randomly assigned, selected, how many of them participate in your study really? It is possible that the people who participated are the highly motivated one. And then we miss the non-highly motivated one. Or they may have other characteristics. They are more educated, or they are women than men. Of course, women participate more in studies than men. And so when we are making our inference, we can't confidently say that it is representative of the underlying population, even though we have done random sampling, because we'll have dropouts, we'll have refusals, no respondents. Of course, we can use different statistical methods to try to correct this. But just to let you know, it is not an easy process when we do that. And so there are rooms for bias to occur, even when we do random sampling. And then we'll collect data depending on the type of instrument you're using. If they are objective instrument, you have calibration. Sometimes the calibrations may not work. If they are to the extreme, where you are asking people questions, there are rooms for record bias, different kinds of biases. All right. And when you collect, you have collected from the participants, you as the investigator, there is also room for you to make mistakes in the data collection and processing. And then you come to data analysis. Many times people misuse the data analysis. And by the way, next year, the widely awaited data analysis course, SFI will bring in that on board next year so that we can guide you through how you can fine-tune your data analysis and do it properly. And now, so you do the data analysis. Many times people use the wrong approaches. People use complex models. What the models are doing, they don't even understand. Okay? And they run these things and they bring the numbers. And if you go to the level of data interpretation, even the data they have analyzed may wrongly be interpreted. And so there are huge rooms for biases to occur in this. Now, why I'm bringing this is that when you test your hypothesis and you calculate the p-value, the p-value does not in any way recognize anything you have done here, does not recognize it at all. Whether there are biases or whatever, the p-value does not give you any information about those. All right. So when you present your numbers estimate, let's say you present means, or you present proportions, percentages between groups, those who were locked down and those who are not locked down. That number you present, we have, like you have seen in the abstract I've given you now, makes an inherent assumption that the processes used to collect these processes here and analyze and interpret were fully correct and all biases were excluded. You see that? That is a big assumption to make. And the p-value, when you calculate p-value, it does not address any of this. It's like garbage in, garbage out. So the p-value is not a probability that one's result were obtained by chance. It's not a probability that your results were correct. It's not a probability that your data collection was well done, that your data analysis was well done. No, it's not that probability. It's a probability that helps you to decide whether the null hypothesis should be rejected or it is true. All right. The other thing you see is that the p-value is actually a continuous estimate. I said it ranges from 0 to 1. The smaller it is, the more likelihood that the null hypothesis is should be rejected. All right. The p-value is not a dichotomy, but when you go to the literature, you see people we very commonly we use p-value less than 0.05 as a cutoff to decide whether your results are statistically significant. P-value less than 0.01, p-value less than 0.001. All right, this is what we do. Of course, I can't blame any of you, and you can't blame me. The issue is that many of us were born into these things, and then some of us just pick them, handle them like the Bible. My p-value is significant. Wow. But I want to tell you that these cutoffs are arbitrary. They're arbitrary, very much arbitrary. When you do this, it means that you have up to 95% chance that your result is correct. This is 90%, is it? Or 99? And this is 99.9, I think so. All right. But the p-value is not a dichotomy. This is arbitrary. And so what the implication of this dichotomy is that it will encourage researchers to engage in hunting for small p-values, using ethically questionable research practices, doing it multiple times until they try to find so-called significant results. That is what this will do. And that is why in some journals, when you do your study, they will say present the p-value as the p-value values as a whole, not a dichotomy. Present as a whole. All right. So just to let you know, because this is tips and tricks. When you find these cutoffs, you should know that this is not originally the way p-value. So what has happened is that then scientists wanted to make a decision. Okay, how do I know at what stage do I decide that this null hypothesis should be rejected? And dichotomies like this were made. Of course, our old peers will always try to solve matters. We will wake up from somewhere and then we take what they struggled with and start using it in the way they had not actually proposed. All right. And then we take the p-value is less than 0.05. My results are true. Really? Is it true? When we don't know how your data was collected, we don't know how your sample was selected, and so on and so forth. All right. The p-value does not tell the truth. Why? The p-value does not measure the probability that the studied hypothesis is true, or the probability that the data were produced by random chance alone. All right. And what is the study hypothesis? That effect I have explained to you. The p-value does not tell us that it is true. The p-value always gives us information of deciding whether we reject null hypothesis or not. It does not tell the truth. All right. We are measuring the probability of observing a certain value, not the probability that the hypothesis is true. All right. Now, this is the issue. We are interested in that value I've explained to you. That value that will make us understand whether the COVID-19 lockdown COVID-19 had impact on mental health. We need that value, the value that gives, whether you are calculating proportion of people, or you're calculating certain other estimate odds ratios, or risk ratios, or all kinds of ratios you're calculating. We are interested in that value, and not just on the value that indicate to us whether the null hypothesis is true or should be rejected. Even when a p-value is interpreted correctly, it is silent on the magnitude and range of an effect. Yeah, that is what I've just explained. So when you take up the p-value, you do not have accompanying it the other information that are actually more important than the p-value itself. More important, because it is that value, the magnitude of each or the range of each, that will give us an idea of what to do if peradventure COVID-19 is a problem on mental health. So it is that value that gives us that information, and not the p-value. The p-value is a function of the sample size. Large and infinite sample sizes in a study will produce small p-values, all right, which are not necessary indicators that the effect estimates are meaningful. That is it. If you have a study of 20 people, increase it to 100, you will see how it is reflecting in the p-value. Increase it to 1,000, you will see how it is reflected in the p-value. Increase to 1 million, increase to infinity, then you see that the p-value will become so small, close to zero, to the extent you will say that I reject the null hypothesis. All right, based on the p-value. But the p-value does not give us information of the effect that we're actually targeting. So if you have infinite sample size, there is likelihood for you to detect effects that are so small that are not meaningful. All right, this is an example here. You have a study looking at the effect of aspirin on myocardial infarction, and you have 22,000 people in that study. And then at the end, a p-value of this magnitude is reported. As researchers, when you see this, you jump up. Oh, I have found an effect. But the question is, what is the effect? This effect here is around 1%. What does that mean? It means that you have so much people in the study. And so you're able to detect very small effects that are not meaningful. And so when we are doing our research, as a caution, don't look at the p-value first. Don't even look at it in the first place. Look at what effect you have. If this is statistically robust, but practically not meaningful, you can't do anything with this. So focusing exclusively on the p-value when the sample size is large can overstate the practical importance of the study's results and conclusions. Now let's go back to what you have done, and I will unmute you quickly. Let's see. So please unmute yourself. Group one, let me see your thoughts. Any of you can raise your hand. What were the things? Raise your hand and I will unmute you. What were some of the things you observed in your own group assessment of this paper? At least in the light of what we have discussed now, you have some additional information than when you looked at this. Anybody raising the hand from group one? Or any other person looking at what is in front of you? if you're not in group 1, what can you observe in this paper with what we have looked at now? Okay, I have Nelson Kubiweya. Nelson, unmute yourself and speak here.
Okay, thank you, Professor. What I see in this abstracts, it's they use p-value. Well, for what we have learned, so now we started to question a little bit.
Yeah, what do you question a little bit? Are you questioning a little bit or you're questioning big? Why do you question a little bit?
Big, because I don't understand what does it mean.
You see? So they have, you see, this has gone through peer review, accepted, and published. Look, they have done a case control study and they have included certain people. And look at what their result. There were no statistical significant differences. You see, they said differences between the two groups regarding percentage of, you see, they have said percentage of asymptomatic patients, and then they put p-value. You see, they measure differences, which actually is the goal of this study, to find differences. All right? And then they measure percentage. And what they have done is that they have quantified these differences by percentages, but we do not have information about the percentages that reflect the differences. They just gave us p-value, 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 p-value. Now, what is our other observation you can make from here? I said, if you have small sample size, this study is small.
Yes,
all right. So even if you have a difference of, let's say, 50% difference in percentages, this study is so small that it may not catch that difference because it's small. Increase it, increase to 1,000, then you see that you have p-value that is small, but our goal is not a p-value. We want to know what is the percentage difference that we can observe, even when the p-value is big. All right, so that is a key problem with this. So thank you, Nelson. Let's go to the second one. Yes, you can recognize a name in authorship here, but just close your eye to that name and tell me, group 2, number 2, what did you observe in this paper? Anybody from group number 2 or anybody from the room who wants to add, wants to speak here? All right, Nelson again. Go ahead.
Yes, I'm the member of the group 2,
okay,
but we didn't finish the discussion. But from what we see, it's in this paper, in contrast with previous one, this we don't have p-values. We have the estimation with confidence intervals, but we don't have p-values. This is the big difference that we see in this paper, and we can understand the magnitude of the difference. Yeah,
and they also the magnitude and
the direction
and the range. Yeah, the direction and the range.
The range, exactly.
The range, yeah. Okay. All right. I have Anne Fat Ogunjobi, please.
Good afternoon, sir.
Good afternoon.
Yes, sir. Yeah, on that screen, I can see that there is no p-value there, but there are plenty confidential
confidence intervals.
Confidence intervals, yes, with ranges. That's what I can observe there. Thank you, sir.
All right, thank you. So you see what is going on here. You know, in this paper, the question is, do you actually need the p-value in this paper? No. One of the tricks is this: with the confidence interval we have given here, we can estimate the p-value. In fact, the p-value gives similar information as a confidence interval. All right, gives similar information as a confidence interval. In fact, the confidence interval is an estimate of the precision of the paper, of the study or the result, the precision, how precise it is. Because we are calculating ratio. If the ratio includes 1, so ranges from less than 1 to above 1, then we know that that estimate is imprecise. But if it doesn't include 1, like this we have here now, we have, for instance, this one, 0.83, and it ranges from 0.76 to 0.88. It means that it is precise. If you use this to estimate the p-value, you see that the p-value is very small. The p-value is very small. All right. So let's go to the next paper. Group number 3. Group number 3, what did you observe? Or anybody from the session can speak. All right, let me help them. You can see that this paper includes the estimates they have set out, as well as the p-value. They include the estimate as well as the p-value. But one thing that is not optimal, and I wouldn't encourage any of you to do, is to include only the point estimate and then the p-value. Why didn't they just include the confidence interval? All right, which gives the range of the point estimate. They just put the p-value. As I said, the confidence interval will give similar information as the p-value. But since you have chosen to include the point estimate, then finish your work by including the p-value. And the problem is, because the p-values were small here, the authors chose to, put the p-values there, But now, if you look at this odds ratio, 1.01, because since it's a ratio, the point of null effect is 1. So you have 1.09, okay? It's around 10%. In some contexts, this is a negligible effect, while in some contexts, it may be an important effect. And this p-value is at borderline. I would be happy to have seen the confidence interval. All right, I have Anifat again.
Yes, well done, Prof. What I can see on my screen is that the odd ratio is greater than 1. It means that the odd ratio, the exposed group are of the harmful side than the unexposed group in this case. Means that the odd ratio greater than 1 is harmful association of the paper.
Of the exposure on the outcome.
The exposure, yes, sorry.
All right. Okay. So I have John to come in.
Thank you very much, Prof, and good afternoon to all. Please, Prof, I'm just worried. In the third line or fourth line, the p-value there is given as less than 0.00. Is it appropriate to report like that, or at times we are asked to maybe put a figure like 1, which does not make
this one?
Yes, Prof. Yes, Prof.
Yeah, so because the p-value is so small, this will take space. All right. Sometimes the journals have recommendation on this, and this is not a problem. This is not a problem. This is not the same thing as I've said using a cutoff. This is just reporting that there are so much zeros, so we can't continue to write 0, 0, 0. That is why we have to teach at this stage. So this is fine.
Okay, because I remember in one of the presentation, the student was asked, the statistician asked why they did like that instead of maybe adding 0.0001 than to leave it like that. So I was wondering.
Yeah, okay. Yeah, I mean, you can add that, but if what is after this is still 0, and what is after is still 0, then it makes it longer.
Okay, thank you very much.
All right. What is the take home this afternoon? The p-value does not does not give an estimate in a study. It only tells whether the null hypothesis is true. But not all studies test hypothesis. Not all studies test hypothesis. You have to take this point, very important. Is your study testing hypothesis? If yes, is it appropriate to test a hypothesis? You know, we have exploratory studies and we have confirmatory studies. In most cases, confirmatory studies are studies that really test hypothesis. In exploratory studies, you are there to dig to also help you to generate hypothesis. All right. So if your study tests a hypothesis, report the test statistics, and that is estimate, like in this case, odds ratio, hazard ratio, it can be mean, it can be other things, and along with the p-value. All right. But if your study does not test a hypothesis, p-value is not important. All right, because it's an exploratory study. Report estimate with confidence bounds or intervals to indicate the uncertainty in the estimate. And finally, given the p-value's limitations, as we have indicated, it should not be the sole arbiter of publication. And researchers should always report additional information, especially mean, standard deviations, confidence intervals, the R-square, and effect sizes. These additional statistics do not correct p-values shortcomings. All right. So it's very important that when you do your study, don't be carried away with the frenzy of the p-value. Although I understand that in many journals, this has become a criteria. If you have set your cutoff as 0.05, many journals use as a criteria to accept. Many times, this is also as a result of ignorance. All right. What is happening in the scientific field now is that many organizations, many journals are taking a stand against the p-value, not because the p-value is bad, but because people have exonerated it to the level that originally it was not meant to be. So misuse of these statistics. All right, that is where we end today. The next our research tips and tricks is on the 25th of November, and that is tips for failure. Tips for failure. Common mistakes grant writers make. And on Sunday, if you have not registered, please do so and join us on Sunday. What is in a PhD? Navigating the twists and turns. Bring your friends. Many people still struggle with these things. And then the ongoing application, which ends on the 15th of November on the SFI Art of Scientific Writing course. So please register and bring your friends. All right. We can have one or two questions if there is. Any question? Yeah, I have Nelson. If you want to get the slides, please just put your email quickly on the chat box, then I will send it to you. If you want to get the slides, then we'll send it to you. Nelson, you can ask your question quickly.
Prof, thank you for a wonderful lecture. My question is, sometime in some journals, we have limited space, sometimes in abstract, especially.
Mhm.
So I don't know how to do in this circumstance, because I think writing, sometimes I want to have like writing the confidence interval, it takes a lot of space. Sometimes some journals like 150 words.
Yeah. It is not everything. It's not everything you have found you are going to report, Nelson. So you focus on the most important thing if you have such limited space, but don't ignore your finding, because that is what you actually set out to do. Present that information in the abstract, even though it is quite tight for you. Present that information so that the readers can have the first glance, and then in the paper itself you can give detailed information about the other aspect of the results.
Okay, thank you, Professor.
All right. Okay, thank you everyone for this afternoon. And all right, I have another hand there. It says Galaxy A3. Please go ahead and let's take you as the last person.
Yeah, Prof. My name is Idrisu. This is Idrisu. I'm
Idrisu,
joining from my that side. Prof, I have a question. With regards to the all these acts of the ratio and those stuff, is it discipline based, or because sometimes if you come to the economics people, we normally run probate model, then we do what we call the marginal effect to interpret the results, because it cannot be interpreted in that of the percentages. So I was wondering whether if you're also doing the marginal effect, you must still go ahead and also present the confidence interval that you were talking about. So
yeah. If the marginal effect has confidence interval to present, you present it.
Oh, okay.
Yeah. I know that in most estimates that are there are always indications of uncertainty and variation. For instance, you have the mean, report the standard deviation.
Okay.
All right.
Yeah.
And so if you have the percentages, you can report the confidence interval.
Okay.
If you have the marginal effect, you can have the confidence interval. Give the estimate of uncertainty so that people know what you have found. What is the confidence we put in that? It ranges from 0 to 1,000. Then you say, well, this is too wide. We don't think this is realistic. It gives readers impression of what is there. But if you just put p-value, it has no meaning to what you actually set out to do.
Okay. Thank you.
All right. Thank you, everyone, and see you on Sunday.
Thank you.
Bye.